Hey guys, I'm here to show you how you can use grid paper for 5.3H. It's represent and solve addition and subtraction of fractions with unequal denominators, referring to the same whole using objects and pictorial models and properties of operations. So basically we're going to be creating our own pictorial model with the grid paper. Looking at this, I always like to backwards design. And by the way, there's awesome activities on our TEAC document here. Actually, I'm using one of the activities that are on here. I'm just gonna kind of bring it to life for you. But I want to look at how it's been tested. As you can see, every year it has had a model, okay? And I mean, the verb is represent, so kind of makes sense, right? So I'm gonna show how your students can create models and can find the common denominator for adding fractions using their grid paper. So I'm going to do two examples to show you it works with more than just one. So I'm first going to do 2 6 plus 1/2. And so what I'm doing here is we always want to look at our denominators for this. I have a 6 and a 2. So I am going to create with my grid paper a 6x2 whole. And both holes have to be the exact same. And that's what's so great about the grid paper. They can actually make them the same size exactly. So I need a 6x2, and honestly, I could have done it either way. I could have put the 2 here, 6 here, wouldn't have mattered. But I'm dealing now with the same whole, and your denominators can help guide you in that. Now, I had to create 2 6. So looking at this, I realized I need 6 equal pieces. So very easily I could see with my grid paper how I could have created those 6 equal pieces, and then I shaded 2 out of those 6. For 1/2, I just literally had to find my midpoint and create my half, and then I had to shade 1 out of those 2 pieces. Now, here's what's so great about the grid paper, guys. It literally has the common denominator pretty much outlined for them. So once again, also I've got, if it's 6x2, it's also telling me that my common denominator would be 12, 6 times 2, because I mean, literally guys, it's an array is what you've just created, really and truly. I have 12 pieces here, I have 12 pieces here, but now I'm going to really identify and outline those 12 pieces. How cool is this? It's literally there for them. Now, I'm literally just going to combine my pieces together. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. So I have 10 twelfths. I have 10 out of the 12 pieces. If I were to go and shift this over, I would have 4 shaded here if you need to kind of talk to them about that. Now, obviously from here, I would need to simplify, and I would need to divide both by 2. They're an even number. That's something you can talk to your students about. I have 5, 6. So simplified, my final answer would be 5 6. Okay, so let me show you how it works with this one as well. And I purposefully kind of threw an odd denominator in there, but so now we have 1/3 and 3/4. So once again, it's telling me, the denominator is telling me I need a 3x4, basically array, but this is my 3x4 is my whole. Very important to talk to them about. I need the same size whole. And then once again, I need thirds. So my first one, I made it into 3 equal pieces, and I shaded 1 of the 3. For this one, I did 3 out of I made 4 equal pieces. My denominator is 4, and then I shaded 3 of the 4. Now I know that I have, my array is 3x4, so I have 12 equal pieces here. So now I'm simply going to, funny enough, I didn't mean to do 12 both times, huh? Interesting. And I'm just outlining my 12 pieces now that I've completed my 1/3 and 3/4. Now I have the same denominator for both of my wholes. So basically I have 4/12 and I have 9/12. So now I'm just gonna count my pieces and combine them, and I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Ooh, 13 twelfths. So in this case, it is improper. So of course, from there, y'all know what to do. I would divide, and I would end up having 1 and 1/12. But you know what? I'll do it just to show. 12 goes into 13 one time. What am I doing? Oops, sorry guys, that's a 1. And my difference becomes my numerator. I would have 1 and 1. Oh, sorry. I'm trying to do this film and write at the same time. It's a little difficult. 1 and 1/12. You could also show how if I moved these 4 pieces, there's only room for 3, so that would be 1 whole, and I would have 1 left over, my 1/12 left over. So visually you can show them all this. This is a great way to help with their understanding of what is going on, instead of just doing your standard algorithm. And honestly, the TEAG says represent, so we've got to show them really what's going on. They have to be able to identify. I mean, look at this. They have to interpret what's going on here. I know this one's subtraction because of our x's crossing it out, but literally this is a good one, for example, for combining as well. So anyways, that's just, I don't want this to be too long, but I wanted to show how you could concretely pictorially really help with their understanding of adding unlike denominators. I know it's a tough one. I've been there. I've done that in 5th grade, and this would truly help them with their understanding.